All right, today we're going to get back into our limits here. We're going to look at some new styles of limits, like how it could be possible for it to not have a limit at some point in the domain. Um, so we're going to look at those cases. We're also going to look at some examples that are going to be like some of your homework problems that I give out tomorrow. Okay, so a function may fail to have a limit at a point in its domain. It doesn't necessarily always have to have a limit at a certain point. So if we're looking at these functions as x approaches 0, then we have to look at it from both different directions, as it approaches 0 from the left and as it approaches from the right. So the very first one, part A, when I look at that, I can draw a very crude graph here, and I'll see what the problem is just from drawing my graph. So if I'm looking at anytime x is less than 0, my answer is 0. And so if I draw my line in red representing where it's less than 0, then it's going to come up to this point, anytime x is less than 0, it's going to come to this point, and at 0, it's going to be an open circle. So it's 0 for every number less than 0. So negative 10, when x is negative 10, y is 0. When x is negative 5, y is 0. But then when x is greater than or equal to 0, y is 1. So if this is 1, then starting here, it's going to be at 1. And it's going to stay at 1 forever, going to the right. So I'll need to throw an arrow on this one, and an arrow on this one, to represent that it's always happened. Now right here at x equals 0, if I'm looking from the left, as I approach 0 from the left, so moving to the right, approaching from the left side of 0, I know that it's always going to be 0. But when I approach 0 from the right, it's always going to be 1. So here I have two different approaches. I'm going from the left and get 0, and going from the right I get 1. So because it's not defined as the same from both sides, it's a different number depending on which direction you come from, the left or the right. That tells me that there is no limit as x approaches 0. Probably the better way to write this is going to be the limit as x approaches 0 of u of x d n e does not exist. You might as well get used to writing both this notation, the limit as x approaches 0, and dne, because it's going to happen a lot of times in the future. Okay, my next one for part B is g of x equals 1 over x, as long as x is not equal to 0. And it's 0 when x is 0. So now if I draw my graph here, I don't like that line. Let's get rid of that. Just going to do a rough sketch of my x and y axes again. Then it's 1 over x anytime x is not equal to 0. So start to think about what if x was negative 10? Then it'd be 1 over negative 10. So we would have a spot like right here at negative 1/10. What if it was 1 over 5? That would be negative 1/5. If it was 1 over 1, or 1 over negative 1, sorry, then it would be negative 1, negative 1. What if it's 1 over negative 1/2? That would be negative 2. If it's 1 over negative 1/3, that would be negative 3. If it's 1 over negative 1/100th, that would be down at negative 100. And so you can see I have this curve that's shaping around and it never actually touches 0. Then on the right hand side, if it's 1 over 1, that's going to give me 1. If it's 1 over 1/2, that gives me 2. And so it's curving up in this direction, getting closer and closer to 0, and going to infinity for the y's. And then if it's 1 over 2, that would be 1/2. 1 over 100 is going to be 1/100th. And so this is getting, our y is getting closer and closer to 0 as x goes closer and closer, or further and further out towards infinity. So this line is always going to be getting closer to 0. I can graph these actually on Desmos as well. And so I can graph these on Desmos and I can say y equals 1 over x. And you'll see our 2 lines appear from our other graph. And then y equals 0 when x equals 0. It didn't really do much. I could do also just 0, 0, because when x is 0, y is 0. So by doing this, I can see this graph pretty clearly now. So as I approach 0 from the left, and I'm getting closer and closer to 0, you notice that my numbers are going further and further negative for the y. So it just keeps going further and further negative. So this is going to be approaching, the limit as x approaches 0 from the left is negative infinity. From the right, you notice that I'm not going towards negative infinity, I'm going towards positive infinity. My y just keeps getting bigger and bigger. So the closer I get to 0, the higher my y gets. So these are going in different directions, which means that our limit is not going to exist again. And then where x equals 0, you also saw that this was 0. However, we don't have to worry about the exact point. Remember, we're looking as it approaches that point or gets closer to that point. That's what the limit is. So the limit as x approaches 0 of g of x dne does not exist. Okay. I can put this in now to Desmos for C. I'm going to do sine of 1 over x. Click on these arrows. Sine of 1 over x and that was true whenever x is greater than 0. So I'm only going to be looking when x is greater than 0. there's a way to make this work for intervals, but I just cannot remember what it is. Let's get rid of this. I think if I do the curly brackets, maybe. Nope, still no good. There we go. Curly brackets around what my interval notation is. And then I can do y equals 0. And then our curly brackets when x is less than or equal to 0. To make that less than or equal to, you just push the less than and then equal to afterwards, and it figures it out for us. All right, well, I have this beautiful graph here. From the left, you can see it's approaching 0. From the right, what is it approaching? It doesn't matter how much I zoom in. I just keep getting more and more gaps. I can zoom all the way in, but this whole right side of the screen is filled up, and that's because this is oscillating back and forth so fast that it's actually not approaching anything. I mean, it is just consistently moving. And now you'll see that it starts to space out more through here. However, you see that the limit does not exist because it keeps going from 1 to -1 in such a fast fashion that there's no way for me to tell what it's actually at 0. I mean, I can zoom in as much as I want, and it's never going to give me a clear vision of what I have. And so for one like this, where it's oscillating back and forth so fast, there's no way to tell a difference, whether it would be -1, 1, or 0, or anything in between. You can see no matter how much I zoom in, it doesn't give me a certain point where I can see that this red is converging to. It just keeps getting further and further out. So this one would be the limit of, as x approaches 0, of f of x dne as well. Maybe. Okay, guessing a limit. Guess the value of the limit as x approaches 0, the square root of x squared plus 100 minus 10 over x squared. There's a couple different ways that we can handle this. One would be to start putting in values that are close to 0. Another way would be to use the graphing calculator, which it kind of stinks because I know some of you don't have them. And the last way would be to try to graph it on Desmos and see what we get there. Now you're not going to be able to put the limit part in, but you can put the rest of the equation. And so when we graph this one on Desmos, you can see that it creates this straight line across the bottom. And if I look at when it is -2.67, if I just hold the mouse down and get closer and closer to 0, I notice that something happens with my y. So out here, my y is 0.047. As I'm getting closer and closer to 0, I see that it goes to 0.05. And now it's not changing no matter how close I get to 0. When I actually hit 0, it says undefined. But we knew that because that gives us a 0 in the denominator, the x squared. So we can't have a 0 in the denominator. So let's look at it as I approach from the right. I'm at 0.045, and as I keep getting closer and closer to x equals 0, look at my y. It's 0.049 now. Now it's 0.05. And as I progress and get closer and closer, you see that it stays at 0.05. So that's going to tell us that our limit as x approaches 0 of x squared plus 100 minus 10 over x squared equals 0.05. I'm just guessing at that limit. It's not a precise value, but that's what it sure looks like, because it just keeps getting closer and closer to that number. Okay. Tomorrow we're going to pick up here with exercises 5 and 6. Just preparing you for some homework problems. We're going to go over some homework problems of the same type so that you're ready to go for the homework tomorrow. Sorry about all the missed days of class. Had a family emergency. Grandfather passed away, so I had to miss some days. But we're back on track now. All right, guys. Have a good day.